Okay, here's a video for the notes that you were supposed to submit 9 through 16. And this is just more examples to help you with the homework. And you can get the homework turned in tomorrow. So we left off yesterday on number, and I should have got this earlier, but I was busy doing Zooms for my other class. So don't worry, you can get it in just by tomorrow's class. So they want you to do the first 5 terms. An explicit equation is a rule in which the nth term is defined as a function of n, where n represents the term number that you're on. So like first term, second term, third term, fourth term, fifth term. So if I want to do the first 5 terms for number 9, a sub 1 is just going to be 1 minus 1 over 1 plus 2, which is going to give you 0 divided by 3, which is 0. So the first term in the sequence is 0. A sub 2 is going to be 2 minus 1 over 2 plus 2, which is going to give you 1/4. So there's the next term in the sequence. A sub 3 is going to give you 3 minus 1 over 3 plus 2, which is going to give you 2 over 5. That's 2/5. Okay. A sub 4 is going to give you, let's see, 4 minus 1 over 4 plus 2, which will give you 3 over 6, comma, 3 over 6. And then a sub 5 is going to be 5 minus 1 over 5 plus 2, which is going to be 4 over 7. And you do see a pattern. Like you start to see a pattern. You see that what's happening is the numerators are going up by 1. Okay, and the denominators starting at 4 are going up by 1. Okay, because remember this one was over 3, but 0 divided by 3 is just 0. But there's your first 5 terms in your sequence. And this was the explicit rule, not the recursive rule. Remember, recursion's when you write it with the a sub n and the a sub n minus 1 and the a sub n minus 2 and a sub n plus 1 and a sub n minus 2 or whatever. All those different ones. Let's do this next one. This will be pretty easy. So a sub n is equal to the square root of 3n. So it's, in other words, your terms are a function of n. So when I want the first term, I just plug in 1. So it'll be 3 times 1, which will be the square root of 3. A sub 2 would be square root of 3 times 2, which would be the square root of 6. A sub 3 will be the square root of 3 times 3, which actually is the square root of 9, but there's a perfect square, so you got a perfect pair, so square root of 9 is 3. A sub 4 would be square root of 3 times 4, which is root 12, which will be, you do want to simplify that to 2 root 3. A sub 5 is going to be 3 times 5, which is the square root of 15. And so we've got our sequence is square root of 3, square root of 6, 3, 2 root 3, and root 15. So there's my sequence. First 5 terms. Number 11. A sub 1 is going to be 1 cubed minus 1 squared, which will be 1 minus 0, which is 1. A sub 2 is going to be 2 cubed minus 2 minus 1 squared, which will be 8 minus 1, which is 7. A sub 3 will be 3 cubed minus 3 minus 1 squared, which will be 27 minus, that's going to be 2 squared, which is 16, which will give you 11. A sub 4 will be 4 to the third minus 4 minus 1 squared, so that's going to be 64 minus 27. Which will be, what is 64 minus 27? Whatever that is. A sub 5 would be 5 to the third. Okay? Let's see. 5 to the third. Let's see here. 5 to the third. And then you'll have 5 minus 1 squared, which will be 125 minus 64, whatever that is. Oh, I better figure out what those are. What's 64 minus 27? What is that? 7. 37. Is that 37? Yeah, I believe so. And then 125 minus 64. This is what you do if you can't do it in your head. 61. Yeah, there we go. So we have 1. See, even math teachers have to do some mental math on paper. Okay? So 1, 7, 11, 37, 61. All right? And you can see the pattern that's being used. The next part, a sub 1, is going to be, this is called a factorial. If you've never seen the exclamation point in math, that was actually on the ACT and MCAs. So 1 factorial minus 4. If you've ever been in AP Stats, what's a factorial? N factorial is just the number n times so it counts down from n, and it counts down by ones until you get to 1. So n times n minus 1 times n minus 2 times n minus 3 until you get down to ... until you get down to 1. So for example, 4 factorial, you start with 4, and then you go 3, because 4 minus 1 would be 3, then 4 minus 2 would be 2, and then 4 minus 3 would be 1, so you go down to 1. So that would be 4 times 3 times 2 times 1, which would be 24. If you did 3 factorial, it would just be 3 times 2 times 1, which is 6. If you did 5 factorial, it'd be 5 times 4 times 3 times 2 times 1, which would be, 20, 60, 120. Okay, so if 1 factorial would just be 1. and just by definition, 0 factorial is also 1 by definition. Because a factorial is how many different ways you can arrange something. So when I say n factorial, this is all the different ways you can create arrangements. So how many ways can you arrange one thing? You can only arrange it one way. How many ways can you arrange 0 things? You can only arrange it one way. How many ways can you arrange 5 items? 120 different ways. So if you had 5 things, how many different orders could you put it in? 120 different orders. If you had 3 things, you could put it in 6 different orders. So a factorial is just to figure out how many ways something can happen. Okay, how many different arrangements is what it's called. So 1 factorial would just be 1 minus 4, which would be negative 3. So there's the first term in the sequence. A sub 2 would be 2 factorial minus 4, which would be 2 times 1 minus 4, which would be negative 2. A sub 3 would be 3 factorial minus 4, which would be 3 times 2 times 1 minus 4, which would be 6 minus 4, which is 2. A sub 4 would be 4 factorial minus 4. So that'd be 4 times 3 times 2 times 1 minus 4. And we already figured out what 4 factorial over here was. It's 24, so 24 minus 4 would be 20. A sub 5 would be 5 factorial minus 4. We already figured out 5 factorial over here. It's 120. So 120 minus 4 would be 116. And again, that was 5 times 4 times 3 times 2 times 1 to get the 120. So my terms in my sequence are negative 3, negative 2, 2, 20, and 116. Okay? So those are how you do explicit forms. All right, so can we write an explicit rule? Well, writing an explicit rule is just, can you write an equation? An explicit rule is just an algebra equation, just like you've done before. Most of the ones we do are linear. And if they're linear, it's just repeated addition. And we use multiplication for repeated addition. So look and see if there's a pattern. Like right here, I can see that these are going up by 3. That goes, well, actually, this is interesting. That goes up by 3, and that it goes up by 5, and that goes up by 7. So this is not linear. This is something else. Well, it just so happens when it goes up by odd numbers like that, it's perfect squares. Just, you can see it. 1 squared is 1. So my rule for this would be a sub n is just equal to n squared. That's it. That's your rule. And it works because if you go to the first term, a sub 1 would be 1 squared, which is 1. A sub 2 would be 2 squared, which is 4. A sub 3 would be 3 squared, which is 9. A sub 4 would be 4 squared, which is 64. So I know, or 16. So I know this equation's right. So now I can use it to find a sub 25. So a sub 25 would be 25 squared, which is 625. So there's, that's done. The next one actually is a linear pattern. Linear is when it goes up by, so this was perfect squares. Perfect squares always ends up being a quadratic. Okay, a parabola. Linear goes up by the same thing every time. See, it's going up by 2's every time. So that's just like slope. This is like slope of a line. So think y equals mx plus b. So my explicit rule will be a sub n is equal to 2n, because it's going up by 2 every time. When you have repeated addition is multiplication. Here's times added 2 once. Now you have 2 2's. So you 2 times 2. Now you have 3 2's. Now you have 4 2's. And then 5 2's and 6 2's. So 2n. But here's the trick. You need to get the first term. I need to be able to get a sub 1. Well, if I put in 1 right now, I'd get 2 times 1, which is 2, but that doesn't get me to the 9 that I need. So what I need to do is I need to add 7 to it. So my rule is this. So I go plus 7, because if I do a sub 1, 2 times 1 is 2, 2 plus 7 is 9. Let's see if it works. A sub 2, 2 times 2 plus 7, will that give me 11? 4 plus 7 is 11. What about a sub 3? 2 times 3 plus 7, 6 plus 7, 13. Yep, it works. So now I can use it to find the 25th term. The 25th term would be 2 times 25 plus 7. That'd be 50 plus 7, which is 57. All right. Now it wants me to do an explicit rule and a recursive rule. So an explicit rule is an algebra equation where you go a sub n. So your equation is going to have a variable n in it. The recursive rule is when you do a sub n and you use previous terms like a sub n minus 1. And the thing that you have to remember on recursive is you have to specify what a sub 1 is. Okay? So that's what we're going to do. So let's figure out what the pattern is first. This is going up by, looks like it's going up by the same amount every time. It's going up by 3's. I'm adding 3 every time. I keep adding 3. So it's going to be a sub n. A sub n is equal to 3n, because I repeat the addition. Repeated addition is multiplying by slope. Okay, you got 1 3, 2 3's, 3 3's, 4 3's. So just repeat that multiplication, 3n. All right. And then, but if I plug in 1 right now, I've got to be able to get this first term. If I plug in 1, 3 times 1 is 3. But I want to have the first term start at 4, so I just need to add 1 to it. Now it'll work. So if I plug in 1, for example, if I plug in 1, I should get 4. 3 times 1 is 3. 3 plus 1 is 4. If I plug in 2, I should get 7. 3 times 2 is 6. 6 plus 1 is 7. If I plug in 5, 3 times 5 is 15. 15 plus 1 is 16. So it works. Now let's do the recursive. The recursive is where I go, all right, I can take the previous term. So if I want to get what I have right now, if I want to get the nth term, let's say that term right there, all I'd have to do is take the previous term, 7, so I'll call it the previous, a sub n minus 1, and add 3 to it. And then all I have to do is specify that a sub 1 starts at 4. There's the recursive. And you also know that n has to be greater than or equal to 2, but they don't require that on the MC8. You just got to be able to do this, okay? But n has to be greater than or equal to 2 because it only took 1 term. You only needed the first term to start the pattern because you don't need more than 1 term. Let's see, what is this one doing? That one's going up by, it's going up by half every time. So same kind of thing. It's going to go up by half every time. So my explicit rule would be, let's see here, my explicit rule would be a sub n is equal to 1/2 n. Okay, now if I plug in 1, let's see, is that going to give me the first term? If I plug in 1, 1/2 times 1 is 1/2. Oh, so I don't need anything here. It's like plus 0. I don't need anything here. So my explicit is just 1/2 n. My recursive would be a sub n is equal to, I'm adding 1/2 every time. So I take, if I want to find out 5/2, I would take the previous plus 1/2. So I got to just take the previous plus 1/2. And then I would say, where does it start at? I'm going to let my first term be 1/2. There it is. There's the recursive. So now, hopefully that'll help you with the homework. Do the best you can on the homework. Don't worry, you're going to get some wrong, and some of them are really hard to actually figure out the recursive because some of them are exponential. I know there's ones that are, it's instead of adding the same thing every time, if you go to the homework, I know there's one where recursive. Like this one, number 5, you're actually multiplying by something every time. Looks like to me you're multiplying by -3 every time. So times -3. So -7 times -3, and then net 21 times -3, and then -63 times -3. So the recursive would be a sub n. So you're taking the previous term. So if I want to get 189, for example, I'd have to take the previous term times -3, times that -3. That's a time symbol there. That's not an X. That's a time symbol, times -3. So I'd take the previous. So I'd take -3 times the previous, a sub n minus 1. That's all I got to do. That's it. You just take the previous times n minus 1, and then specify your start. A sub 1 has to equal -7, and then also n has to be greater than or equal to 2. That's not that big of a deal. I just need to make sure you can get this. So there you go.